Hey everyone, and welcome. We're about to dive into one of the most incredible stories in human history, the evolution of computing. We're going to follow the trail all the way from, you guessed it, simple pebbles to the powerful pixels on the screen you're looking at right now.
So you gotta wonder, right? How did we get from just using sticks and stones to count things to building machines that can outsmart a chess grandmaster? That's the big question we're gonna tackle, and trust me, the answer is an amazing story of innovation, necessity, and some seriously brilliant people.
So here's how we're going to break it down. We'll start at the very beginning with pebbles and the abacus. Then we'll jump into the age of gears with the first mechanical calculators. After that, we'll see how punch cards gave birth to the idea of programming. We'll meet the visionary who basically designed the first computer, see how electricity changed everything, and finally connect all those dots to the tech we use every day. It's quite a ride, so let's jump in.
Okay, so our story really starts with a super basic human problem. How do you keep track of stuff? I mean, before calculators or spreadsheets, just counting a large number of things was a huge challenge, and making sure you got it right was even tougher.
Way back, people just used whatever was around them, lining up pebbles, carving notches into bones, or just using their fingers. And sure, that works for small numbers, but you can imagine how slow and messy that gets. Trying to track supplies for an entire village that way? Almost impossible.
And you can see how things slowly started getting a little more sophisticated. Instead of just loose rocks, the Babylonians created the Salamese tablet, basically a board with grooves to keep beads organized. And then, taking that idea even further, the Chinese perfected the abacus, turning it into the incredible tool we know today.
The abacus was a total game changer. It was really the world's first proper calculating device. By just sliding beads on a frame, someone who knew how to use it could add and subtract way faster and more accurately than ever before. It was so revolutionary that it's actually still used in some places to teach kids math.
All right, so for a long time, the abacus was pretty much the best tool for the job. But then, the world started changing. We entered the age of exploration, trade went global, and suddenly, the math got a whole lot more complex. Our ambition was starting to get ahead of our tools.
Seriously, the demand just exploded. You had sailors trying to navigate vast oceans, astronomers trying to map the stars, and merchants juggling complicated finances. The world desperately needed machines that could handle big numbers with perfect accuracy, and a few geniuses stepped up.
And this is where things start to pick up speed. First, in 1617, you have John Napier's bones, a really clever set of rods for multiplication. Then we get the first real mechanical calculators. Blaise Pascal builds the Pascaline in 1642 to help his dad with taxes. And just a few decades after that, Gottfried Leibniz takes that idea and runs with it, creating a machine that could also multiply and divide.
And this right here? This is a perfect example of how innovation works, right? Pascal solves an immediate problem with a machine for basic math. Then, Leibniz comes along, sees what it can do and what it can't do, and builds a better, more powerful version. Every invention becomes a stepping stone for the next one.
Okay, so machines could now crunch numbers. Fantastic. But the next big question was, how do you tell a machine to perform a whole series of complicated steps all on its own? The answer, and you might not expect this, came from the world of weaving.
Back in 1801, a guy named Joseph Jacquard completely changed the textile industry. He built a loom that could weave these incredibly detailed, complex patterns automatically. And the magic wasn't in the gears of the loom itself, it was in these weird-looking cards with holes punched in them.
It's kind of like one of those old player pianos. A hole in the card meant one thing, no hole meant another. So the needles on the loom would either go through the hole or be blocked, controlling which threads were lifted. By chaining these cards together, you could essentially program any pattern you wanted. This was a huge idea, using an object to store instructions for a machine.
And that idea, storing instructions, is what lit a fire under one of the most brilliant minds in history. It's time to talk about Charles Babbage, a man who was so far ahead of his time, he basically designed a modern computer when the world was still running on steam.
So Babbage started out designing a machine called the difference engine, which was meant to calculate math tables flawlessly. But his real stroke of genius was the analytical engine, which he came up with in 1834. Now, it was never actually built in his lifetime, the technology just wasn't there yet, but its design had everything.
And this is just mind-blowing. He imagined two main parts, something he called the store, which would hold the numbers. That's exactly what we call memory or RAM today. And then he had the mill, which would do the calculations. That's our CPU, our processor.
The names are different, but the concepts are identical. He designed a computer more than a century before it could be built.
And we have to talk about his collaborator, Ada Lovelace. She was a brilliant mathematician who saw the true power of Babbage's machine. She realized it could do more than just crunch numbers. It can manipulate any kind of symbol. She wrote out detailed algorithms for it, which makes her, effectively, the world's very first computer programmer.
So Babbage's ideas were incredible, but they were stuck in the world of gears and steam. To really move forward, computers needed a new kind of power, electricity. The challenge now wasn't just about calculation, it was about processing huge amounts of data faster than any human could.
You can see the jump right here on this timeline. We go from Babbage's purely mechanical machine to Hermann Hollerath's device, which used electricity to read the holes in those punched cards, all the way to the Mark I, a fully electromechanical computer. These machines were powered by thousands of clicking electrical switches called relays, and they were the crucial link between Babbage's dream and the electronic age.
And the need for this leap wasn't theoretical. It was a full-blown data crisis. The 1880 U.S. Census took a ridiculous 8 years to count by hand. So, to solve this, Hermann Hollerath built his tabulating machine. It used those punch card ideas from Jacquard and Babbage, and it crunched the numbers for the 1890 census in just 2 years. A massive success.
And this work led directly to the Mark I in 1944. This thing was a beast, a collaboration between Howard Aiken and IBM, and it was the first fully automatic computer. It ran 24/7 for 15 years, and one of the operators said all the clicking relays made it sound like a room full of ladies knitting. Now, the Mark I was amazing, but those clicking relays were slow and clunky. The next big step was to get rid of moving parts. That kicked off the first generation of computers, huge machines like ENIAC that used thousands of fragile vacuum tubes. They were hot, unreliable, and took up whole rooms, but they were also thousands of times faster. Then, in the late 50s, the second generation arrived with the invention of the transistor, making computers way smaller, faster, and more reliable. This led to the third generation in the 60s, with the integrated circuit, which put hundreds of transistors onto one tiny silicon chip. And finally, the fourth generation's microprocessor in the 70s put the entire CPU onto a single chip. And that one invention is what leads directly to the personal computer, the internet, and the device you're probably holding right now.
So where does that leave us? Well, the fingerprints of these pioneers are all over our modern world. From robotics that do dangerous jobs for us, to AI like IBM's Deep Blue, which finally achieved that goal of beating a world chess champion. We see it in virtual reality, in biometrics like face scans, and in the powerful learning tools we all carry in our pockets. Every single one of these things has a direct line back to an abacus, a punch card, and one man's dream of a thinking machine.
So let me leave you with this thought. It took thousands of years to get from the abacus to the smartphone. But think about the insane speed of change we just saw, from room-sized computers to microchips in just a couple of decades. Given that pace, what incredible leaps do you think we're going to see in just the next 50 years?